Oh, hey, Lauren.
Ben, come in.
All right, what do we got?
All right, tell me if this sounds crazy.
Okay.
But you know how there's this tension between direct instruction and constructivism, where the direct instruction people say you should just tell people what they need to know, because some research says that it's more efficient with the same learning outcomes. And the constructivist people will say you should let people build knowledge for themselves, because while it might take longer, some research shows that it gives them better depth of knowledge. But these results are sort of inconsistent, so what's the truth here? Maybe there's a different dimension that's not direct instruction to constructivism that we should be considering. So we looked at a bunch of techniques from direct instruction and constructivism, and we ended up with this theory that says learners develop better conceptual knowledge. So conceptual knowledge like understanding how things work, compared to procedural knowledge, which is understanding how to solve a problem, or declarative knowledge, which is memorizing facts in a field. But better conceptual knowledge, when they're guided, guidance depends on the instructional technique, but they're guided to compare multiple conceptions of a concept. And so what's a multiple conception? So we got different types of conceptions. One is a correct conception. So say you wanted to know the difference between an interval and a float. They're both data types. One has whole numbers and one has decimal points. Now, if you didn't know one or the other existed, then you have incomplete knowledge. You only knew what an interval or a float was. If you misheard something and you thought maybe an interval included decimal places, that would be an incorrect conception. And a misconception is sort of a type of incorrect conception where you're misapplying prior knowledge. So say you had an interval that you divided by another interval and it had a remainder, but you thought you could still store that number, that result, as an interval even though it now includes a decimal point. That would be like a misconception. So it's sort of like, say you're drawing a map of a river. When you first come up to the river, maybe you only see that it's here and there and there. And so that's an incomplete conception. But then, if you know what the incorrect conception is, or what's not a river, what the banks are, you have a little bit more information, and then, say, usually rivers contained between the banks, but you have a misconception, which is that this rock is in the middle, and that's not actually a river, and you're going to crash on it. So now, if you put together all of these pieces, you have a much better picture of what the river is. All right, so how did we get here? So there's 8 different instructional techniques that we considered, 4 from direct instruction and 4 from constructivists. Test-enhanced learning is when you test students along the way, sort of like formative assessment, to see what incorrect conceptions they have and what correct conceptions they have. If you're very clever about it, you can also grab some misconceptions along the way. Erroneous examples, you're giving students examples in wrong solutions to a problem so that they can compare those wrong solutions to the right solution and understand why something's wrong, why something's right. Again, if you're very clever, you can get misconceptions in there too. Analogical reasoning, you have 2 correct examples of how to solve a problem, and you guide people to make analogies between the 2 so that you uncover this conceptual knowledge that governs them both. This is the only type we saw that only had correct conceptions, but you're still comparing between the 2. Refutation texts are compared to explanatory texts. So explanatory texts just tell you what's right. Refutation texts start with, a lot of people think blah 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 misconception is true. But that doesn't make any sense because whatever conception is true. So you're getting misconceptions and correct conceptions along the way. On the constructivist side, you have productive failure, where you give students a problem without telling them how to solve it. You send them into groups, they try to create solutions, and then you bring them all back together and compare their solutions that they tried to make from prior knowledge compared to the canonical solution. So you're putting together their incomplete conceptions to make correct conceptions. Ambitious pedagogy is kind of like productive failure, but instead of sending students off into groups, you're doing a class-wide discussion where along the way the teacher is guiding from incomplete and incorrect and misconceptions, prompting students to consider them and compare them towards the correct conception. Then you have problem-based learning, where you give students an authentic, complex problem to work on. They have to break it down, figure out the different pieces, so that they can put it all together again. And inquiry or discovery learning is sort of like problem-based learning, but instead of it being around this problem, it's a little bit more open-ended. It could be anything really. So again, they're breaking it down so that they can put the pieces back together again. And there's a lot in the literature about these techniques that's really interesting, and I can't have time to tell you right now, but for example, productive failure, they found that if students figure out the solution early on, they do worse than the students who just sit there and bash their head against it over and over, coming up with incorrect conception after incorrect conception. And so they found that the best predictor of success is for them to consider a large number of conceptions. That's even better than figuring out what the right one is. So there's gems of information in the literature of all of these things. I mean, you could literally write a paper about it. So what do all of these things have in common that makes them work? So there's some shared mechanisms that we identified. One is vicarious failure. So you don't have to be the person who makes the mistake, but you can learn from other mistakes by comparing those to the correct solution. Prompting self-explanation is another one. This is a way of guiding that comparison between different conceptions. Inductive or case-based reasoning is when you have two examples or more examples that you compare so that you can uncover the higher order conceptual knowledge. Conceptual growth is when you test people's knowledge so that they can identify the gaps that they have to fill them. Conceptual change is when you test people's knowledge so that they can identify things that they think are right that are actually wrong, so that you can then change that information. And how you apply these mechanisms to the actual classroom made some instructional design principles. So vicarious failure is you should introduce learners to non-correct conceptions so that they know what's wrong and what's right. You should prompt self-explanation so that you are prompting learners to compare conceptions very explicitly. They tend to not do it on their own. Inductive or case-based reasoning, you should provide concrete examples, correct or not, doesn't really matter as long as they're comparing them to come up with that conceptual knowledge. Conceptual growth, you should test learners so that they are identifying gaps in their knowledge that they can then fill in. Conceptual knowledge, again, you should be testing knowledge, testing the learner's knowledge to identify any misconceptions and then show how those misconceptions are correct. So you don't have to do all of these, not across a class, not across a lesson. Mainly, these are options you could use to guide learners to develop better conceptual knowledge by comparing multiple conceptions of a concept. And we already have examples of this in computing education. So we have peer instruction, which is a type of test-enhanced learning where you give students multiple choice questions, you match them up with someone who gave a different answer than they did so that they can compare. More often than not, they come up with the right answer. You also have Parsons problems. Parsons problems, you have lines of code that you put in order to solve a problem. You can do it with distractors so that you have two lines of code that go in the same slot. You have to figure out why one is right or the other is wrong. And that's basically an example of erroneous examples. And then we also have notional machines, which you could spend a lot of time thinking about how to apply to this. I mean, you could write a whole section about it, but basically, maybe it's not the difference between direct instruction and constructivism. Maybe it's just that you need to tell learners what's wrong so that they know what's right. Any questions?